All right, now we are looking at 7.3, and we're looking at special products, right? Product means to multiply, so special multiplying, right? Special things that we get when we multiply. So starting off, we have this square of a binomial, right? And this is a pattern that we can use sometimes. And now this is something that I often will do in my head, now that I've been doing math for 10 years, right? I've known this for over 10 years now. So I use this tool, this trick. Um, if you don't like this trick, if it doesn't click well with you, that's okay. You can always just do it the longhand, right? Up top, we had, where was it? Like example 10, we multiplied out. That will still work for all of the problems that we're looking at now, okay? Now, this is just kind of a trick that we can use. Looking here at our rules, if it so happens to be that we have a plus b squared, and that could have been written as a plus b, right? To square means to multiply it by itself. If we notice that we have that pattern, we can square the first term, square the last term, then say 2 times the first times the last. Okay, what that means here would mean that if we had x plus 5 squared, we could jump to the end and we could say, well, the first term squared, that's x squared. The last term squared, that's 25. And then the middle is 2 times x times 5, which is 10x, which is what goes in the middle there. Okay, if that works well for you, that's awesome. If you don't like it, you can still take the x plus 5, and you can multiply them. That'll give you what? X squared plus 5x plus 5x plus 25, x squared plus 10x plus 25. All right, these are the same answers because we're doing the same process, okay? If you like the shortcut, that's awesome. If you don't like the shortcut, that's also awesome. Here, I'm probably going to more often show you the long way because I want to really reinforce this process here that we've been working on, okay? That's the way that I'm going to do them. If you like the shortcut, you're welcome to use the shortcut. Now, next up, sums and difference pattern. Now, we might have talked about conjugates before. Conjugate's a fancy math word. It is whenever you have a binomial, like this, and then another binomial where the middle piece, right, the middle symbol, right, the plus, is switched. And what happens with a binomial, or excuse me, what happens with conjugates when you multiply them is that you're left with just a binomial at the end. And I'm going to show you that in a problem that we do in just a couple minutes. Let's look at example 13 here. 3a plus 7 squared. Now, right here, that's a good time to use the formulas that we had up top. You could say that this is going to be 3a squared plus 2 times 3a times 7 plus 7 squared. Okay, this would be, let's just go ahead and write this out. This would be what? 9a squared plus, I don't know, 42a plus 49. Okay, and that's our answer. Now, that's awesome if you do it that way, but I'm going to show you the longhand way to do it. You take this guy and you break him up in two. So we're going to have 3a plus 7, and then another 3a plus 7. And then now we distribute like we did on the last section. The 3a goes to 3a. 3 times 3 is 9, and then a squared. 3a times 7 is 21a. Then I look at my second piece, the 7. This is going to be 21a, and 49. Something to see here is our pattern is showing up. We have our 9a squared. We have our 49 and our 49. And then these middle pieces, right, that's the same thing added up, right? So you can kind of multiply by 2 instead of adding them. That's how they get the 42 from the formula. So 9a squared plus 42a plus 49. And there we are. Next up, example 14. Now again, we could use this formula, but I'm not going to. I'm just going to skip straight to just doing it by hand. So to square something needs to multiply it by itself. So I'm going to break them apart, and I'm going to say 4d minus 5 and another 4d minus 5. Now, whenever I multiply, I'll take 4d and I'll distribute to both of these. That'll give me 16d squared minus 20d. Then my negative 5, that'll give me a negative 20d plus 25, right? The double negatives go to a positive. Now, combining these middle pieces, I get 16d squared minus 40d plus 25. And that is my answer. All right, example 15. Now, something to notice is that these are conjugates. Okay, I think, if you want to write that word down, I believe it's where it's spelled conjugate. I'm hoping that that's the right spelling. Okay, conjugates, same in the front, same in the back. The middle pieces are swapped. Okay, the plus and the minus are changed. And something fancy always happens with conjugates. Up here, we combined, what did we combine? We combined these two guys together. With conjugates, the two middle pieces would cancel. So let's look at that. Whenever I distribute, I have u, I'll get u squared, then negative 6u, positive 6u, and then negative 36. We look at our middle pieces here, and we have negative 6 and positive 6u, right? Those add up to be 0 u's, or just 0. So I'm not even going to list them. I'm just going to say u squared minus 36. And that's that. Now, this piece down here, this is called a difference of two squares, because you could say this is u squared minus 6 squared, and we're going to use that later on. But it would be a good idea to just start thinking about that as being a difference meaning minus, right? There's a minus symbol there, of 2, because there's two pieces, squares, because you could write them as pieces squared, u squared and 6 squared. All right, but for today, we're good with just this piece right there. All right, let's scroll on to the next one. This one again is a conjugate, right? We got 9c plus 5 and 9c minus 5. So again, we should recognize that. We should say, well, later on in the problem, something should cancel out. So 9c and 9c is 81c squared. Then we get negative 45c, positive 45c, and negative 25. Our middle pieces cancel, which is what should happen, right? With conjugates, that should happen. We should be expecting that. And then we get 81c squared minus 25. And that's that. Scrolling down, again, we have a conjugate, right? The same piece in the front, same piece in the back. So 7x times 7x is 49x squared. And what I'm going to do here is I'm going to say, well, the middle pieces are supposed to cancel. So I'm just going to skip all the way back down to the end. Right there, that's going to be negative 81y squared. And that's our answer. What I'm doing there is I'm using this formula. Where do we want to say it? Right there. When we have two conjugates, it's the first piece squared, or the first piece multiplied by itself, minus the last piece squared. So right here, I multiplied the first two, that was my blue swoop, and then I multiplied my last two, that was my black swoop, and I kept the minus, because the minus should have been kept. All right, that is everything, and next up, we're going to be solving stuff. All right, again, these top formulas, if you don't like them, that's okay. Okay, I didn't really use any of them besides right up there. All right, that's that.